Okay, it's our hydrogen generator seal oil video. Have to apologize for the mess. It started out as kind of a clean drawing. Now it looks like a seal oil skid. Time we put a lot of the stuff on it. The basic layout of this drawing. This part here is the actual generator. You have your hydrogen cooler. Some have them on top, some have them on the ends. But you're using water to cool the hydrogen. This would be the generator shaft coming through. One end's the slip ring end. One end will be the turbine end. We have two different seal oil systems we're showing on this. The seals, this part here will be on the bearing frame, generator end of it. You won't see all this. If you look underneath, you'll see some of the lines going in and different parts of it. Same as this end. This will be the generator bearing housing end of it. The dark pink is the hydrogen side seal oil. The orangish yellow is the turbine lube oil on this. The one system is a vacuum treated seal oil system. It's a little simpler. And this is a double flow hydrogen seal oil system. It's a little more complicated. The purpose of the seal oil is to use oil to lubricate the seals. Anytime the generator shaft is turning, you have to have seal oil on to prevent from damaging your seals. They also keep the air out of the unit and hydrogen in the unit. In reality, these seals are probably a little smaller than what I'm showing here. They're not very big in reality. We drew it kind of big, try to make sense of this. The basic principle of operation, you're using oil, same as the turbine lube oil. Part of the oil flow is inside. This keeps the hydrogen in the unit. A slight amount of hydrogen is picked up with the oil. The other part of the oil flows out and keeps the air out of it. You have to have fairly clean oil, otherwise you're going to release moisture and air into the generator housing, contaminate the hydrogen. This system, the vacuum treated, is quite a bit simpler. You have oil come from your turbine lube oil system. There's a valve, a level control valve in the vacuum tank. The oil is sprayed in the top. This is under a vacuum, probably 30 inches of mercury, something right around there. Have a vacuum pump, pulls vacuum on it. This removes any air, water, any contaminants. From here, the oil is pumped through a gear type pump. There's a relief valve that maintains the pressure. About 2/3 of the oil is sent back to the vacuum tank. So there's quite a bit of contact area between the oil and the air in here. So this removes most of the dissolved gases and moisture out of it. From here it goes to your seal oil regulator. These are very accurate regulators. They have the seal oil on part of it, then the other part is the hydrogen side. A lot of them I've seen, they're taking the hydrogen pressure off the oil tank, which is under the hydrogen pressure. That way you're not having hydrogen gas come down to this. But this maintains the oil, seal oil above the hydrogen pressure. This unit's about 8. There's different pressure ratings depending on the manufacturer. So this is maintaining the seal oil above the hydrogen pressure. That's the key part of this. From here, the seal oil goes up to your seal. This just has one line feeding in. There'll be the same setup on the other end of the generator. Seal oil is split. Part of it goes to the hydrogen side and part goes to the air side. From here, the air side combines with the bearing oil coming out. So this oil is sent together to a loop seal tank. This is like an enlargement or de-entraining tank. There's a vapor extractor on it trying to pull vacuum to remove any hydrogen gas out of this. From here, the oil is going back to the lube oil tank. The hydrogen side, it comes down, there's a loop inside, a little vent on it. It goes down to a drain line down to the drain regulator tank. There's a loop seal from the other side of the generator coming back. That way the hydrogen won't cross flow between the ends. This will be a small loop in here. They have a float switch. If the level gets too high, if the drain regulator tank malfunctions, it'll trip this and let you know that you're starting to flood. You don't want to dump oil back into the generator. They do have leak detectors on these on both ends, and usually one in the middle. Depends on the size of the unit to tell you if you're starting to have a problem with seal oil running back in. Drain regulator tank. It's the same pressure as the generator hydrogen. There's a float valve in here that maintains a level. It just de-entrains any hydrogen. Lines are big enough they can flow back up through this vent, so it maintains pressure as the generator hydrogen. Here, the oil returns back to the loop seal, any vapors extracted. If the turbine lube oil system shut down, it can take oil off the loop seal tank. The vacuum will pull it in, goes through your pump back up, and instead of going back to the turbine lube oil, it's recirculated back. The problem with that, it'll build up heat in time. There's a backup 125 volt DC pump. They all have backups on these. You do not want to lose your seals with a generator that has like 60 pounds hydrogen pressure or even more. There's a lot of hydrogens from the bigger units, and that coming out can be a bad deal. One rule of thumb, keep your generator pressure where the next backup system can handle it. So this backup pump will run the same as the main oil pump, but your next backup is the bearing lube oil, which would hold the pressure down to maybe 2-3 pounds hydrogen pressure on here instead of what you're normally running at. So this is really a emergency backup. The problem with this, you cannot maintain much hydrogen in the generator. You'll have to dump this real quick. So this is a fairly simple system for smaller units, vacuum treated. Turbine lube oil comes in, strip out all dissolvable all the gases and moisture. It's pumped up through a seal oil regulator, maintains this pressure above the hydrogen pressure, so you can force oil in to seal, and the oil goes out to keep the air out. These seals float, they're pinned so they won't turn, so they have to move. It's really a good sealing system. A mechanical seal wouldn't work. This is the double flow. This is a little more complicated. Same color scheme. Dark pink is the hydrogen side. Orange yellow is the bearing oil side. This has two separate pumps on it, two separate systems. We'll start with the hydrogen side oil pump, another gear driven pump. It comes off. There is a pressure regulating valve. Since it's a gear pump, you have to maintain flow through here. These have oil coolers, temperature control. Should run like 110 degrees or something to try to cool the oil going back. Okay, this is the same setup. They'd be the same seal on the other side on the generator. Seal side oil comes up. This will feed the other end. It comes into the generator side hydrogen seal. This has a hydrogen side DP control that's set the same pressure as the air side. The air side is actually doing the controlling of the seal oil pressure. So this valve maintains the pressure across the air side, and hydrogen side the same pressure. In reality, this would be sitting down here on the skid. I do it up here just for convenience. Okay, the generator side comes in, part of the oil here, it hits the air side oil, so then it flows back to the generator side. This is the hydrogen. Goes to a defoaming tank. They got a high level on it. Like I say, these, if you look underneath the generator end, you might see a little change in the housing where this is located. From here it goes down, it's called a drain regulator tank. This is the hydrogen side seal oil. You have one valve that lets oil in to maintain the level. This is coming off the air side. This is a drain, opens up and dumps it back to the air side suction or the turbine bearing. So there's two floats in these that maintain the level. From here it goes back down to the hydrogen side pump. So this is the flow loop of this, the hydrogen side, this pump, oil cooler, control valve. There'll be 2 of these on the skid, 1 for each end of the generator. This keeps the hydrogen from in the system. The air side of this, it's running this part of it here. It basically comes off the bearing oil. You have your pump suction, air side gear pump. There's a pressure regulating valve, maintains the pressure. It's another gear pump. From here the oil comes out through the oil cooler. It's temperature controlled. Here is your seal oil regulating valve. This unit run at 60 pounds, set like at 12 pounds. Pressure seal oil above the hydrogen. So this is really what's regulating your seal oil pressure right here. Same scheme. They're taking the seal oil pressure and then they're also coming off the defoaming tank. This will give you your hydrogen pressure without bringing a lot of hydrogen down here. From here you have your 12 pounds pressure. Now it's fed up here, feeds into the seal. The air side comes in, hits the oil on the hydrogen side, and it flows back. So there's kind of a barrier here. The oils stay separate. Here the oil drains off with your bearing lube oil. Drops out. You have a enlargement or loop seal tank. Another vacuum pump on it, vapor extractor, trying to remove hydrogen gas. From here, the excess oil returns back to the lube oil tank. You have your suction line coming off to the air side. So this loop runs like this, continuous. The big thing on these are backup. You have a backup side DC oil pump on this. It'll maintain the same pressure as your air side pump. If you lose your hydrogen side pump, it doesn't really matter. Your air side will take over the sealing job. That's why they got the seal pressure regulator on the air side. So if you lose this, the air side will back up. About 2/3 of the oil going through the seal is on the air side. So just to run the air side pump, you can still seal the machine. But you will introduce a lot of contaminants into the hydrogen. So if you're running just the air side, you're going to have to probably purge more on the hydrogen to maintain the purity in the generator. So you have your 125 volt DC backup pump. This pump here will maintain the seals. Some of these have float oil on them that float the seal. Like I say, the seals float. There's a lot of dynamic balancing on it. Some have floats, some have different float pumps. There's different schemes to this, but this is the basic scheme for this. Okay, if you lose these 2 pumps, there's a backup seal oil pump that'll run. The pressure regulator dumps the oil in. It will maintain the system. You also have your pump off the main turbine that puts high pressure out. You can get oil back in here, maintain seals. If you drop down to bearing lube oil, you're in trouble because this has to be dropped to 2 pounds. It does not have enough pressure to maintain this. I believe this will stay sealed as long as you have 3 pounds seal oil higher than the hydrogen pressure. On your last ditch, you got to dump the hydrogen quickly if you lose your seals. Seal oil is always higher than hydrogen pressure. You do not want to run a generator without seal oil on it. It'll damage the seals. Like I say, in reality, these seals are probably about that wide. They're fairly narrow, come down to 2 nozzles, a whole bunch more nozzles on the air side than the hydrogen side. Say these regulators maintain hydrogen side pressure equal to the air side. They should be within an inch or 2 at most. These are all sitting down on the skid. So this whole part here would be on your skid. That's why there's such a complex piece of piping. Why do we use hydrogen? It's 7% density of air. The windage loss decreases to 10% if you're using air, so you get a 1% efficiency improvement. It has 7 times the thermal conductivity, has 1.35 times the heat transfer coefficient, so it's going to pull the heat out of the windings and rotor much better. Output unit weight increases, so you can have a higher megawatt output machine for a lot less material and costs. Eliminates the corona damage to windings. Keep generator clean and moisture out. Some of these run like 30 recirculations per minute. You have your fan blower and your rotor, so it's shoving the hydrogen down the rotor. Has a bunch of holes that's blowing up through the stator windings. Say the coolers either be on top or on the ends, it depends on the setup. But they do have leak detectors looking for cooler leaks, seal leaks. So if you're getting these go off, you need to pay attention to what's happening. Some of these blowers will put out like 3 pounds pressure across here. Big thing about hydrogen, it's explosive from 4 to 75% in air. It's lighter than air, so it'll collect on high points. If you're welding and working around these areas, you should probably purge out the generator. Anytime you drain these systems, or even if you put this thing on air, well, first you use CO2 to get the hydrogen out, then you'll use air to get the CO2 out. There can still be hydrogen trapped in these various pieces of equipment. So anytime you work on this, you gotta be aware of hydrogen. These units are pretty sensitive. I wouldn't be adjusting any controls unless you know what you're doing on them. You can create a lot of problems quick. But the big thing is you need to keep the hydrogen in the generator. Some of the bigger units, the higher the pressure, the more heat they can remove and the higher the megawatt load to a point. If the higher loads, you'll have to use water-cooled windings. There's different things they can do to increase the power output. But basically hydrogen, the higher the pressure, the more generator load it can put out. Smaller units, this is real. See a lot of this, like some will run a half a pound, may put out 13 megawatts, and then if they go to 30 pounds, they can put out 28 megawatts. Anyhow, this is kind of a basic overview. We don't have any of the pressure switches or a lot of the stuff on this. They have seal oil strainers on the discharge, keep any debris out from plugging the holes up on them, and some different things on them. They usually run fairly well, and they're kind of forgotten about. Like I say, the dark pink is the hydrogen seal oil, the orange yellow is the bearing oil. This one has 2 separate systems running. Your seal oil pump running through cooler keeps this oil circulating here. This one, a lot of the oil is bearing oil going back through it, so this is a little bit dirtier oil. But it is a good backup system. Like say if you lose this, the air side's going to take over instantly, keep hydrogen out. This one's a lot simpler. You have one line coming in from the turbine, lube oil. It flows through, and all the oil ends up going back to the turbine. Say this is the generator part here. These are generator bearing ends here. It's not drawn to scale, but it's just trying to demonstrate 2 different systems and kind of how they work. Big thing, they want to keep the hydrogen in the generator, keep the air out, and lubricate the shaft seals. Anytime working with hydrogen, you need to be very diligent. Just remember that it's lighter than air and it will accumulate in the ceilings and high spaces. Anyhow, that's our generator hydrogen seal oil. Hope that wasn't too confusing. But if you look at any of these seal oil skids, they do look pretty confusing. They're really fairly simple, just with a lot of backup stuff on them. And that concludes our video.